Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 20th March 2023. The problem statement for today is shortest XY distance in grid. This problem is based on dynamic programming and BFS. Let's now open this problem to solve it. Let's go through and understand the given problem statement. Given a n into m grid of characters O, X and Y, find the minimum Manhattan distance between X and Y. Okay, so again one-liner problem statement. So we will be given a simple 2D array here, and it will be consisting of characters like O, X and Y. So we have to find the Manhattan distance between X and Y. So what is Manhattan distance? So the formula is given here: row index of X minus row index of Y plus column index of X minus column index of Y. So at one position we'll get X, in another position we'll get Y. So we have to do X and Y. That means we will get two coordinates for X and two coordinates for Y. So we have to do the subtraction of X coordinate and Y coordinates, and we need to add them. So Manhattan distance is calculated as the absolute difference between the row indices and the column indices of two cells. Specifically, Manhattan distance between X at position ij. Suppose we have some X is located at position ij and Y is located at position kl. Then it is given as I minus k. That the absolute distance of here the absolute distance of I minus k plus j minus l. That means absolute distance between the X and plus absolute distance between Y. Okay, so let's go through the given examples. So here in example 1 it is given n is equal to 4, m is also 4, and this is the given grid where it consists of characters like O, X and Y. So here the output is 1. In explanation it is given this, the characters in bold shows that these two are at the minimum distance. The shortest distance between X and Y in grid is 1. One possible such X and Y are marked in bold in the above grid. So this one, these two. So if you look at the coordinates of this X, so what it will be? If you look at this this 2D array, and if we consider that one base index, so this is at the 1, 2, 3, third row, second column. This is a fourth row, second column. So here the columns are same. So the second part of Manhattan distance, this part, so the columns are same, so it will contribute to 0, but this one, rows are different. So we have to find the absolute distance between this row. So here it will be 4 minus 3 is equal to 1. So that's why the distance is 1. Let's go through the second example. Here in second example, here n is 3, m is 3, and this is the given grid. Here the output is 2, and here, as in the previous solution, the one of the such solution has been marked in bold. So this X is considered and this Y, because between these two X and Y is the minimum distance. The shortest distance XY distance in the grid is 2. One such possible combination, this one. Here also, if you can see, this is the first row. If you are considering that one base index, that means first row, second row, third row. So this is in X is in the first row, second column, and Y is in second row, third column. So if you see the distance between X, that means the relative distance between X, absolute distance. So here it will be, here the row number is 2, here row number is 1. So 2 minus 1, that is 1 there. And if you see the distance, column distance, so here the column number is 3, here the column number is 2. So again the distance is 2. So 1 plus 1, that gives the answer as 2. So here another way to look at this is, from this X to reach Y, we don't have to take diagonal distance. That means Manhattan distance doesn't consider the diagonal distance or the displacement distance. So we have to move one step down and move one step right. So one step down, one move, and again when we move to the right, add 1. So 1 plus 1, 2. Similarly, if you consider this route, so from X to this route, one distance, from then this O to this Y, one more distance. So this again 1 plus 1 will give you 2. So we don't have to consider the diagonally distance, else we have to go to either, we have to go to the we have to go to the nodes in between those two, x and y, and we have to take even those two in count. So from x to y we have to go through this way, so 2 steps, or through this way, then again 2 steps. So that only is the Manhattan distance that we are calculating using formula. So I hope this is clear. So to solve this one, we will solve it in 2 approaches. Okay. So here the first approach we can use is the brute force search of the grid to find the minimum Manhattan distance between x and y. We iterate through each cell in the grid and checks if it contains x. If an x is found, then we iterate through the entire grid again to find closest y. For each y found, the algorithm will calculate the Manhattan distance between x and y coordinates and updates the minimum distance and the coordinates of the closest x if the current distance is smaller than the current minimum. I hope this is clear. So this is the first approach we will follow. So let me add that code here for the first approach. I have already prepared it just saving for the time in typing. So here I'll tell what all things is getting done. So here what we are doing, we are initializing in the first approach. Here this is a brute force approach. So here we are initializing x row and x column to -1 to keep track of the track of the nearest x. To keep the track of the nearest x found so far. Then we initialize the minimum distance and initialize this to integer dot max value to keep the track of the minimum distance found so far. So initially we initialize it with maximum value possible. Then as and when we found something smaller, then we will update. Then we iterate through each cell in the grid. If the cell contains x, then we iterate through each cell in the grid again. Then we check if the cell contains y. Then calculate the Manhattan distance between x and y cells. If the calculated distance is less than the current minimum distance, then update the minimum distance and x and row accordingly. So if we find that whatever distance we get, that is less than the previous one minimum distance, so we will update minimum distance and x and y. Then at last return the minimum distance found in the previous step. If no x and or y is found in the grid, the code will return whatever it was initialized earlier with the maximum value. Suppose if this doesn't contain any x and y, then this will never be true. So the code will return the minimum distance here, whatever it was initialized earlier, if no updation was done. Okay, to check that there is no valid distance was found. So I hope this is clear. So let me try compiling this code. So here we can see we have got correct output. Let me try submitting the solution. So here we can see it has passed all the test cases. But one problem is there. So talking about the time complexity of this one, this is in the order of n square into m square. That is the problem here, where n is the number of rows in the grid and m is the number of columns in the grid. This is because there are 2 nested loops that iterate through the entire grid, and each iteration involves checking the value of the current cell, which takes constant time. Therefore, the overall time complexity is proportional to the product of the number of rows and number of squares in the grid. The number of rows and columns in the grid, resulting in a quadratic time complexity. This is not efficient for large grids. Though we have got, it has covered all the test cases, but it is not that efficient in case of large grids given as input. So to optimize it, we will go through the second approach. So the second approach which we will follow, which will be the optimized solution for this one, that is that approach, that is not any algorithm in particular. That approach will simply uses a straightforward approach to solve the problem. The solution consists of 2 parts. The solution will consist of 2 parts: populating tool list of points objects for x and y's respectively, then calculating the minimum Manhattan distance between any pair of x and y's in the two list. So okay, so that will not use any algorithm in particular. It will simply try to find the coordinates of x and y, all the coordinates of x and y, and store it in the list. And once those two lists is populated, then we try to find the minimum distance between any two pair of x and y in the two list. Okay, so let me remove this code completely. And let me take the different solution. I'll explain this one as well, the what all things is being done here. Let me just verify if all the brackets are properly done. Okay. This is getting closed here and this is getting closed here. Okay, so fine. Yeah. So here in this approach, what we are doing in this optimized algorithm, so here we are creating two array list here. This is x list and y list. This is list to store position of x, and the second list is to store the position of y's. Okay, then what we do, we iterate through each point in here. What we'll do, we first iterate through the 2D grid here and store the position of x and y in the two separate lists which we have created here. Okay, that is x list and y list respectively. To store the position, we use custom point class with two fields as row and column. So to store the coordinates of each x and y, we are using a class here that we have created separately. This one, it contains of two fields there, row and column. So row will contain the row number and column will contain the column number of the location of x and y. So using this, we are creating an object, and that object we are adding it to x list and y list. That means we are simply storing the coordinates of x and y as a object in x list and y list. I hope this is clear. So x list will store the position of x in this, and y list will store the position of y, all the position of x and y. Okay, after these two lists are populated here, after these two lists are populated, then we iterate through each point in x list and each point in y list. Then we compute the Manhattan distance between them using the formula of x dot row minus y dot row plus x dot column dot minus y dot column, this formula, and update the minimum distance variable if the computed distance is smaller than the current minimum distance. And finally we return the minimum distance. I hope this point is clear. So again, we are creating two lists, x list and y list. X list will contain all the position of x, y list will contain all the position of y's. Then once these two lists are populated using this piece of code, then we we try to find the Manhattan distance between x and y using two objects in reference. That means first one, x is pointing to the one object from x list, and y is pointing to one object from y list. So using each of these combination, we try to find the distance, and if it is minimum than the current minimum distance, then we update the minimum distance. And at last, once this iteration is done, then we return the minimum distance. I hope this is clear. Let me try compiling this approach. So even for the second approach, we have got the correct output. Let me try submitting the solution. So here, if you can go back to the previous solution, then we could see the previous solution took more time, but this took lesser time. So talking about the time complexity of this particular solution, it is big O of nm plus xy, where n and m are the dimension of the 2D grid which is given in the input, and x and y are the number of x and y's respectively that is present in the list. This is because we need to iterate through the entire grid to populate the two list of the point objects, and then iterate through each point in the two list to compute the minimum distance. This solution is faster than the brute force solution that we had seen earlier as a first approach, because it avoids nested loops over the entire 2D grid, which can be very slow if the grid is large. Instead, we only iterate over the much smaller X list and Y list. That's why we have got some better time complexity here. So I hope even this approach is clear, or this solution is clear. So this way we have solved this question with two different approaches. One was with brute force, and another one was using a point class to store the coordinates in the list of X and Y. So I'll be providing the link for this question in the description box. Please do check that. That's all in this video. If you have any doubt related to either of these solutions, please drop a comment in this comment section of this video, and then please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.